So this will be our final session. This will be our final session for tonight. And we're going to look at recursion or recursive functions. So before I proceed with this, let me just say this here and now. They are basically, let me see. They're basically four types of functions.
But one important.
What do you say? Nina, what was it?
Four.
I'm not sure I can hear you. Error. So these are the four types of functions we have. User-defined or customized functions, built-in functions, recursive functions, anonymous, or lambda functions, right? So we've treated user-defined functions. That's what we've been basically all through, right? Built-in functions, you have used them. I mean, you've used the print function. You've used so many built-in functions, input, integer, so many functions that are built in. Now, when we say built in, what we mean is that they are built in with Python. So they come with Python in the Python standard library, right? So that one we mean by built in. Then we have recursive functions, which we want to deal with now. Then the last one, which is anonymous function, also known as lambda functions. That one, you guys will go and read up on it. Read for this and practice with at least 3 examples. Yeah. So read up on this and you practice with at least 3 examples, right? That's for the lambda functions. We'll get this tomorrow. We'll submit this tomorrow. This will be an assignment, so make sure you prepare yourself and do this tomorrow. So we've looked at user-defined or customized functions. This we are defining a function yourself. The name can be anything you want to give it, right? Built-in functions. Now, well, I wouldn't say the name can be anything you want to give it because you have to be careful. So you don't give it a name that already exists in the built-in function. Just like your variable name. It would be wrong for you to say you want to name your variable name something that exists. Let me understand now. You want to say this is wrong because in is a keyword in Python. So you don't call your function def in, right? Or def is or def print. You see it doesn't make sense this way. Right? So you can just say print if you want to put it that way. Or sum. You see, these are built-in functions in Python or keywords. So you don't name your function name a name that already exists, right, in the Python kind of library. You have to be very careful. Now, we say recursive function, they are function that calls themselves, right? When they're executing a particular task. So let's look at an example, or we look at 2 examples. Let me say 2 examples. We look at 2 examples of that. Now, with recursive function, it's important to understand something that it works like a while loop. And if you're not careful, the chances of that function executing to infinity can occur. The chances of that function executing to infinity can occur because it can keep on calling itself and calling itself if there is no condition or there is no condition that terminates it, right? So you have to be very careful about that. But usually you can use recursive function to solve problems or tasks that involve several iterations. Tasks whereby you need to repeat some things over and over again, right? You can use recursive functions to get. Now, there's this thing we call factorial. How many of us remember factorial in school? If you did mathematics, you remember factorial. How many of you remember factorial? I think this is in university, even secondary school, you do factorial. I think even your primary school, you do factorial, like primary 6 and 5. Abi? 2 factorial, 3 factorial, 4. This is what I'm saying. I mean, you guys remember, I remember did maths then. You did maths in your, I mean, it might not be as a major course, but probably as one of your courses, your courses that you did, like modules. So when we're talking about factorial, please let me don't assume. How many of us know about factorial? I don't want to assume that you can just know it.
I think it's multiplication of numbers from
Yeah, something like
probably
that.
1 to infinity.
Exactly. Something like
Yeah.
that. So when we talk about factorial, there's a formula for it actually, right? So I think if I'm not mistaken, formula should be like let's say we have n factorial. This is usually written by exclamation mark, like this. So the formula is going to be given as this n times n minus 1, right, times n minus 2 times, usually, in math, you don't put times like this. You don't mind me anyways. Usually in math, because this is times already. N minus 3, times
Àti bẹ́ẹ̀ bẹ́ẹ̀ lọ.
So it goes to what? To n minus
Infinity.
n factorial. That's the formula. You understand? It goes to n minus n factorial. Now, before we proceed, that means if you have, let's say, 4 factorial. 4 factorial, I'm just giving us, this is just mathematics, like mathematics here. 4 factorial will be what? 4 times
3
times 2
times 2
times
times
1.
1.
And that will give you what? 4 times 3 is 12. 12 times 2 is 24.
24.
24 times 1 is still 24. If you have
24.
if you have 5 factorial, if you want to follow the formula, it's very simple. You can say 5, like we said, times 5 minus 1, right? Times 5 minus 2 times 5 minus 3 times 5 minus 4, then times 5 minus 5 factorial, right? That's what we said. So if you have 5, if you want to do this now, this will give you what?
5 times 4 times 3 times 2 times 1.
Okay, thank you. 5 times 4, right? Times 3, 5 minus
Times 2
right? Times 2. 5 minus 4 is 1, right? 1. Then 5 minus 5 is what? 5 minus 5 is 0, right? But don't forget, anything times 0 is 0. Don't forget that. That's why there is factorial at the back of that thing. Because if you have, what you're going to have basically is, you're going to have times 0 factorial. And 0 factorial here would give you 1.
Is
You understand that? So if you don't put that factorial, you have lost its essence. That's exactly it. Because you have 5 minus 5, which will give you 0. And n times 0 is 0. So you always have 0. It's important to put that factorial. It's very, very important. So 0 factorial is 1. So if you have this, your final answer will be what? 5 times 4 is 20. 20 times 3 is 60. 60 times 2 is 120. 120 times 1 is still 120, right? So your final answer was 120. So this is just us explaining factorial mathematically. Mathematically speaking. So now let's see how we can implement this factorial in Python. And we're going to use this recursive function, right? So let's have this. We can say the factorial, right? Now I'm going to pass a parameter called n, right? Now I can say if n is equal to 0 or n is equal to 1, I can say return 1. Now don't forget, we're going to return statement because we want it to be reusable, right? That means if I instantiate it to an object, I can always use the output over and over again. And I can say else, if this is not so, I can say return, sorry, I can say return n times, then I'll call my factorial function n minus 1. And this is it. So now let's instantiate this factorial to, let's say, number equals factorial. So I can say number equals 4. So if we say 4, we expect to have 24 based on our mathematical calculation, right? If I should run this now, you see it now, I can say 24. If we try for 5, let me try 5. Say none, 5, if you have 120, like this here, 120. So if we come and try a bigger number, if you still have the same thing, no, we can say 100. Let's see what on the factorial will be. Oops. It's a very long number, here it is. But how many of you can pronounce this number? Where are the scholars in this place? Where are the scholars in this place? Alessandra is laughing. This is a simple question. How many people can call this number? We are scholars now, aren't we? Imagine your younger one bringing this tax to you. Oh, Sir Alexandra, can you help me? What number is this? Oh, brother, go, sir. What number is this? If you look at your number, my friend, go and see that. Right? I mean, this is even, I don't know. I don't know, honestly, I don't know. But I mean, it has to have something, right? This is like nine, is it nine quintillion or 9 zillion 330? Okay. Cannot be 9 zillion. 933 zillion 262 some. I mean, it's a very long one because this is like 100 times 99 times 98 times 97. Oh my gosh, it's a long one. It's a long one, right? So let's explain this code real quick. Now you can see we have a factorial function, and I'm using factorial just to make it descriptive enough, right? we can use any other function name. You don't have to be factorial, right? It can be any other function name, right? So, the factorial here, we are saying that it will take in a parameter called n. N can be anything, don't forget, it can be anything. We said if n is 0 or n is 1, return 1. Why are we saying that? Because the reason is because 0 factorial is 1. Same thing as 1 factorial. Because 1 factorial give you 1 times 1. Right? It's still 1. Right? 0 factorial, we all know that 0 factorial is 1. So if n is 0 or 1, just give us 1. Don't waste our time. Otherwise, return n, whatever number it is, times, we call the factorial function again. So because we are calling it here again, right? That means, remember I said a recursive function is one that calls itself while executing the particular task. So in this case, this factorial function is calling itself here. You can see it here. It's calling itself. Hence, it is a recursive function. Right? We now said n times factorial n minus 1. And the reason why we said n minus 1 is so that it can terminate. Because if you don't do that, if you just keep on looping and looping or iterating and iterating, and would have an infinite function or infinite recursion. And that's not good. We don't want to have that. So we said factorial n minus 1. And that is just, you might come across this in any interview question or stuff like that. You come across this, depending on the kind of interview question you're doing. But it's a common interview question. Let's take one more example, then wrap up. You are kidding me, right? 93 decillion, 326 duodecillion. 215 on decillion. Please, what is decillion? How many numbers is decillion? Because I think I know
10, I think
10, Abi.
yeah,
Okay. Wait.
10 followed by 9,
It
8,
cannot be.
7,
It cannot
6,
be
5,
10.
4.
Calm down, calm down. What is million? Million is 6. Abi? What is 7?
Yeah,
7 digits what? 7 is what?
we have 7 is septillion.
Is it seption or septillion?
Septillion.
Septillion. 8 unko?
It will be octillion.
Octillion. 9.
Nonillion.
Nonillion. Then 10. 10 is what?
Decillion.
Decillion. So why are you having decillion there? And duo, that would be like Duolingo.
That do will be 12. 12 will be 13.
Okay, so when you
3
say
and 10.
decillion, I say like 12 times 10. Is that what you're saying?
No. The number of I think it should be the number of zeros.
I mean, tre there means like 3 now. So decillion
Yes,
means
tre
like
is
30.
3. Then we have deck after tre. That is tre deck.
That's 30, Abi.
So that is 13.
Is it 13 or 30?
Okay.
No, it cannot be 13. It cannot be 13.
Yeah, 30.
When you say 93, count it now. 13 self is like
Yeah.
it reach this place.
Yes, 30.
Oh, guy, you try you. I go
No, it's not me. I used this ChatGPT.
chat. Of course, you think your brain can process this?
What am I doing?
Your brain cannot process this. He said, if I know the waste time on calculation when nothing is involved.
Have better information to put in my head than all this.
Oh gosh. Man, but this is interesting anyway. This is interesting. Well, there's this saying, numbers have no ending, right? Numbers have no ending.
Yes.
So if your happiness is dependent on numbers, in this case money, because money is numbers, right? If your happiness depends on money solely, trust me, your happiness will be insatiable because numbers have no
Yes.
ending. So that's just a food for thought. Never let your happiness be dependent on money because money is infinite. Your happiness will be insatiable. Because if you have, you always want to have more. You always want to have more. You never for once be satisfied. You understand? And that's not good. But well done. This honestly, if I tell you I've learned this thing, what I've learned that there's something called decillion. There's something called tridecillion, duodecillion, octillion. There's even sextillion. Father Lord. Okay, I think I know quintillion. I know quadrillion, trillion, billion,
Yes.
million. You know those ones. Billion. So 1,000,000,000, billion, trillion, quadrillion, 20. Hey, someone asked, what about zillion? Where is zillion? Because I think we've heard zillion. Maybe we've not, maybe we've not reached zillion in this case. Because I think I used to hear zillion too. But I know I've heard thousand,
Yes.
billion, billion, trillion, quadrillion, quintillion, sextillion. So, man. This is this is huge. Well done. So, back to our factorial example. Anybody with any question on this, please? We'll take one more example, then we'll just wrap up. Okay, no one's asking a question, so I want to believe we all got this. So the next example would be taking is what we call Fibonacci. How many of you have heard of Fibonacci before? I think it's one A double I. I think that is Fibonacci.
FX traders.
You said?
FX traders.
FXK. Which FX? FX traders. How come? I'm lost.
I think it's one of their indicators now. The retracement.
They use
Fibonacci.
Fibonacci sequence in FX trading.
Yes.
That's interesting. I don't know. That's interesting. So let me explain Fibonacci for you guys. Or is there anyone who knows it? If you explain to us, if you know what I mean, okay. The man who said FX trading should know it already. Oh yeah, come and give us. Do you know how it works? I think you guys, you think we do Fibonacci in school then? I think so. I can't remember now. But this is how it works, anyways. The way it works is a sequence, right? It's a sequence, a sequence of numbers. But those numbers, they have like an algorithm and formula with which they are generated. Now, the idea behind Fibonacci sequence is the first two numbers are usually 0 and 1, right? The first two numbers are usually 0 and 1. Now, the way it works is that the sum of the last two numbers will give you the next number. You get the sum of the last two numbers will give you the next number. That's how it works. That's the logic behind Fibonacci. So in this case, we have 0, 1, which are the first, always really the first two numbers. 0, 1. Now, if you add this, what will you have as the next number?
1.
1. Right? Now, what do you think the next number will be? The last two numbers in this case is now what?
2.
1 and 1. So if you have 1 and 1, you have 2, right? So good. What will this now give you?
3.
3.
3. Okay. Next number.
5.
5.
5.
8.
8.
13.
13,
13,
21,
21,
34,
4. Oh, yes.
34, right? Okay. Then the next one, we'll just wrap up here.
55.
50.
All right, good. Now, at least you know it now. So that's the idea behind Fibonacci, right? So you can see it. Well, if someone looked at this number, you might not really get it at first, right? I mean, if you don't understand the logic behind it, right? So if you just come across it, if you don't understand logic, you will not really understand it. But if you understand how it works, I mean, it's not difficult. It's not difficult. It's not difficult. So now, we want to write a Fibonacci function, or if you sorry, a recursive function that can implement this Fibonacci sequence. So, just like I did with the factorial, I'm going to use the word Fibonacci, taking the parameter n. N can be any number, right? So, if n is 1 or less than 1, we can say, let me say, if n is less than or equals to 1, we can say return 1, right? Because, no, let me say return n. Because usually it's always, if n is 1, to give you 1, then this, I want to give you what n is. This can just it. So we can say else, right? Else, we can say return. So we're calling the function here Fibonacci. Then I'm going to perform a decrement because I need to perform a decrement, otherwise it won't get to the last place. So n minus 1, I'm decrementing by 1, then I'm adding it to what? Fibonacci n minus 2. So this is it. This is the function, right? Calling the function in 2 places. And I'm decrementing and I'm adding. So Fibonacci n minus 1. So if n is, let's say, 5, n minus 1 will give me 4. Then n minus 2 will give me 3, something like that. So the last 4 and 3. Right, that's what I just said. So now let's get, let's say results here equals. Now I'm going to use a list comprehension. I hope you see about list comprehension. I hope you know list comprehension. I'm going to say Fibonacci, right? I'll pass in norm. I can say for norm in range, I want to give it a range of numbers. I can say range 10. I say result. That's what we have. So you can see it now. 0, 1, 1, 2, 3, 5, 8, 13, 21. I think just like the other. See it. So it's giving me for 10, like 10 values. Do you guys remember this comprehension? We've done it before. So that's what we are doing here. Any question, please? Before we proceed. Wrapping up soon. Any question? Any question, please? Are we together? Any question?
Can you go over it again, please?
we have less than 10 minutes here, and I want us to do 10 minutes perfectly well, right? So what we are doing is we define a function called Fibonacci, right? And we're saying um we're saying this. It takes in the parameter, which is n, of course. You understand? And we are saying here, if n is 1 or less than 1, we are saying it should return n. Return n. Now, else return the Fibonacci function. Now, because because it is a recursive function, we have to terminate it. When I say terminate it, is that we have to make sure it gets to 0 or 1, right? Otherwise, it will keep on iterating and iterating. And just like we have for the factorial, that's why we didn't just call factorial n, made it n minus 1. And of course, remembering that we have to reduce, decrement the factorial. Now, the way the Fibonacci works, considering the formula, right? You are taking the last two numbers and you are summing them together. You are summing them together. So that's what we're just doing here basically. We are taking n minus 1, summing it with n minus 2. So suppose n was 3, take for instance. Remember, in this instance, n has to be greater than 1, right? So if n is 2, take for instance, if n is 2, what will be n minus 1? N minus 1 will be what? 1, Abi? And n minus 2 will be 0, because n is 2. Do you understand that?
Yes.
Yeah. So if n is 2 in this case, let me just put it. Let me run this. Okay, let me just put on this here. Right. And let me call the result. I'll just do this. Let's say we'll put into the range. Can you see it now? The range is now 0 and 1. Because we just want to do output. So if n is 2, here we're going to have n minus 1, which is 1, n minus 2, which is 0. So it will stop at n minus 1. By the time it goes again, n minus 1. By the time it goes again, n is 1, Abi. It will come here. If n is equals to or less than 1, return n. Right? So it would have returned 0. If n were 2, by the time it does the first iteration, n minus 1 plus n minus 2. N minus 2, that's 2 minus 2, that's 0. Right? N minus 1, 2 minus 1 is 1. If you do 1 plus 0, that is 1. By the time it goes again, n is 1. N is less than or equal to return n. 1. Right? Else, if it comes here, n minus 1, now the 1 minus 1 will be 0. It won't even come. I think, let me get you the mathematical formula for Fibonacci if I can get you that. Because if you don't understand the mathematical formula, you won't even get this, the code at all.
Almost like this.
So this is the formula here. Let me put the formula here for you. The formula is given as I'm using a Fibonacci formula, right? It's given as this. You have n of n that is equals to f n minus 1 times plus f n minus 2. It's like saying function of n is equals to function of n minus 1 plus function of n minus 2. Now, one task I want to give you guys, like I said, read up on lambda function. Like read up lambda function. Another thing I want to read up on is this. Read up on the 4 main principles of OOP. Yeah. Read up on the 4 main principles of OOP. So let me just give it to you here. They are basically encapsulation, abstraction, polymorphism, and inheritance. Yeah. So with these two assignments, right, from here, I'll drop this file for you guys, right? Just for you, I'll drop this file. I'll drop the HTML file. Then I'll push the recordings to the channel as usual, so that we can have access to it. For those of us who want to watch the recordings again, just to understand what has been done. Maybe you missed some part of the lesson, you can always watch it again. So I'll put the recording up there. Right. So, but I'll drop this also on the group so that we can have access to it, right, and practice. Please, this assignment would collect it tomorrow, like would ask for it tomorrow. You understand? So don't be reluctant. Don't say, I mean, there's no time. It's tomorrow evening, same time, 8 p.m. Right? We look at encapsulation, look at abstraction, but I want you guys to go and read up on them, right? You can even look at examples on them, right? So that when we meet tomorrow, the flow would be, well, what word do I use now? That's a better flow, right? They're made up of lambda functions. How do they work? Yeah, why are they called anonymous function? Right? So read up on these things. I said there are basically 4 main types of functions. We have the customized functions, built-in functions, recursive function, and lambda functions. We looked at 3 of them. The last one I've given you guys as assignment. It doesn't mean we won't probably treat it, but I will treat it with the assumption or with the belief that you guys have also read about it and practiced it, right? So I'll be assuming several things. You understand? So any question before we close? We are done for tonight's class. I think we've had roughly 3.5 sessions or about.
What's the time for tomorrow's class?
8 p.m. I think we all agreed to move it to evening. So I would say something about Akaran on the group, right? But I wanted to give us a tax on Akaran. So, but considering time, I'll just drop it on the group. Since we have less than a minute here. 8 p.m. we'll meet tomorrow. Like God's grace. In the absence of no questions, guys, have a wonderful night's rest. Sleep tight and God bless you.
Thank you for your time.
Thank you and good night.
Mr. Adams, thank you. Good night.